Welcome to Impact Signals, social impact at the scale of AI. I'm Charlie.
And I'm Sarah.
Monday, April 6th, 2026, episode 51. Today we're exploring the operational maturity of AI in disaster response, from weather forecasting to humanitarian assistance, at a moment when technology breakthroughs are shadowed by the worst humanitarian funding crisis in a decade. Let's start with what might be the week's most operationally significant story. On March 12th, Google Research published a landmark paper on AI-powered urban flash flood forecasting. Sarah, this is different from Google's existing river flood work, correct?
Exactly. Google's Flood Hub already covers 700 million people across 100-plus countries with riverine flood forecasts. But rivers, those we understand pretty well with traditional sensor networks. But flash floods in dense urban areas have been systematically underserved because you need real-time precipitation data at extremely high resolution, and weather stations don't exist everywhere.
So how did Google solve that?
They used LSTM neural networks trained on meteorological data from NASA, NOAA, and the European Center for Medium-Range Weather Forecasts. But here's the innovation. They built something called Groundsource. It's a system that uses Google's Gemini model to extract ground truth flood event data from unstructured news articles. Think about it. Journalists report on floods in real time. That's data.
So they're training the AI on news reports?
Exactly, which means you get ground truth labels for places where formal flood monitoring doesn't exist. The result? Model accuracy in South America and Southeast Asia now matches what they had achieved in high-income countries with dense sensor networks. That's a parity gain that will save lives.
And forecast lead times?
Extended from 48 hours to 7 days, with 250,000 virtual gauge points now shared with researchers in 150 countries. This is operational infrastructure at scale.
Let's talk about another operational milestone. NOAA, the U.S. National Oceanic and Atmospheric Administration, deployed 3 new AI-driven weather models in February 2026. These aren't research prototypes. They're operational. What do they do?
They're called AI-GFS, AI-GEFS, and HGEFS. The critical breakthrough is compute efficiency. A traditional weather model, the GFS, requires enormous computational resources to produce a 16-day forecast. NOAA's new AI models generate the same forecast using just 0.3% of that compute. It runs in 40 minutes.
0.3%. That's not hyperbole?
That's the published number. An HGEFS, the hybrid ensemble, consistently outperforms the classical ensemble model. For humanitarian response, the most significant gain is in tropical cyclone track prediction at extended lead times. That directly translates to longer evacuation decision windows.
There's a flagged limitation, though.
Yes, tropical cyclone intensity forecasting still needs improvement, but the trajectory is clear. What previously took supercomputers now runs on accessible infrastructure. An NGO in the Global South can now integrate these models into their early warning system.
Speaking of AI approaching problems from new angles, there's a really fascinating paper from April 4th about mapping wildfire damage. CA-MTransU-Net, sorry, that's an acronym within an acronym, fuses satellite imagery in a novel way.
Cloud-aware Mixture of Experts Linear Transformer Unit. I know, it's a mouthful, but the engineering is elegant. After a wildfire, you need to map the burned area to calculate recovery funding and ecological impact. Traditional optical satellite imagery gets obscured by smoke and cloud cover, so these researchers fuse Sentinel-2 optical data with Sentinel-1 SAR, synthetic aperture radar.
SAR penetrates clouds?
Microwave frequencies go right through, so the model learns to rely on SAR data where optical data is compromised. The accuracy is 87%, and the inference speed is 6.26 milliseconds, near real time.
That's not just a fire mapping tool, though. This is a template for other disaster contexts where cloud cover is the problem.
Exactly. Monsoon season floods, cyclones with persistent cloud cover, wherever you need information and the sky is obscured, multimodal SAR plus optical is now the approach.
Let's pivot to climate adaptation. There's a new paper on seasonal drought forecasting that researchers are calling a breakthrough. AI for Drought, published in NPJ Climate and Atmospheric Science on March 25th.
This is about long-range prediction, drought forecasts 6 months ahead. The traditional problem is that climate models are good at global patterns, but bad at regional detail, and they're uncertain. So researchers built a hybrid transformer network that doesn't just predict a single value, it produces a probability distribution of possible outcomes.
Walk me through the architecture.
They take outputs from 4 major global climate models, combine them with reanalysis data, basically historical observations, and run an AI post-processing step that corrects regional biases. Then they calculate drought indices, SPI, SPEI, the standard metrics climatologists use.
And the reliability?
About 90% for same-month forecasts, above 60% when projecting 3 months ahead. That's genuinely useful for anticipatory action.
This matters because WFP and other agencies run anticipatory humanitarian programs. They pre-position food and water based on forecasts.
Exactly. If you can predict droughts 6 months out with above 60% confidence, you can move resources into position before the crisis intensifies. That changes the operational model from crisis response to proactive adaptation.
So we're seeing maturation across the full disaster lifecycle. Early warning systems that now cover dense urban areas, weather models that produce forecasts on commodity hardware, drought predictions with usable precision. But humanitarian agencies are under severe resource constraints. Are these technologies reaching the organizations that need them?
That's the central tension. Let me point to 3 examples of deployment. The American Red Cross won an AWS nonprofit grant in early 2026. They're building Clara AI, a multi-agent generative AI platform designed to respond with empathy to people seeking help.
Multi-agent, not single chatbot.
Right. Different sub-agents handle disaster relief, blood services, military family support, life-saving training. It routes queries intelligently and generates contextual responses in real time. The prototype is being tested right now.
Why is Red Cross doing this?
Volume and scale. During a disaster, Red Cross receives thousands of simultaneous requests. Staff and volunteers can't respond individually to everyone. AI agents that understand eligibility rules, shelter locations, and service availability can triage and respond at scale, while staff handle the most complex cases.
Second example.
The World Food Programme's Innovation Accelerator is scaling 3 platforms. CRISTA, built by the Asian Institute of Technology, combines vulnerability mapping with crowdsourced community incident reports. It turns communities into active data collectors for their own disaster risk.
That's a different model from top-down sensing.
Completely. Then there's AAvance, a blockchain digital wallet for Latin America. It enables cash transfers to unbanked recipients in minutes via mobile phones. That solves the last mile problem, where disbursement delays can be deadly.
Cash assistance is the most efficient form of aid. But in countries with collapsed banking systems, you need alternative infrastructure.
Exactly. And the third is WASDI, Web Advanced Space Developer Interface. It's an open-source platform that pulls satellite data from ESA Sentinel, Copernicus, NOAA, and Planet, then runs algorithms to generate flood and wildfire maps in near real time, used daily across Southeast Asia.
These are all digital public goods, open source or community-based infrastructure, rather than proprietary tools.
That's the sector's strategic shift. Instead of relying on vendor lock-in, humanitarian organizations are building digital public goods that can be maintained, improved, and adapted locally.
One more funding story before we close. The UNDP Climate Catalysts program launched today, April 6th, an 8-week fellowship for early-stage climate tech entrepreneurs across Asia-Pacific. Microsoft is co-sponsoring.
This targets youth-led innovations: AI, IoT, emissions monitoring, water quality tracking, risk mapping, early warning systems. The fellowship provides mentorship on investment readiness and access to a network of incubators and accelerators.
What's significant here?
Big tech is not leaving climate resilience to bilateral aid. Microsoft is explicitly investing in climate adaptation capacity in the Global South.
But here's the underlying issue. Climate adaptation technology investments surged 64% in 2025 to $5.5 billion. That's remarkable growth. Yet the 2025 humanitarian appeal raised $12 billion against a $33 billion target. That's the lowest funding in a decade. 25 million fewer people were reached in 2025 than 2024.
The efficiency imperative. AI-powered tools are being positioned not as force multipliers, but as survival mechanisms, enabling agencies to stretch diminished resources further. Technology cannot substitute for this resource gap.
It's a profound tension. The field is developing increasingly sophisticated tools to do more with less, but more with less has its limits. You eventually hit a floor where there simply isn't enough resources, no matter how efficient the tools are.
That's the conversation we need to be having. The technology is mattering. NOAA's weather models, Clara AI, WASDI, these are real. But without adequate humanitarian funding, we're optimizing around a constraint that may be unsolvable through efficiency alone.
That's Impact Signals for Monday, April 6th. If this briefing is useful, subscribe wherever you get your podcasts. Check us out at impactsignals.ai and share it with someone working in the field.
Stay ready.